equal to whatever that you get. So let's just try and calculate that. 5RA minus 15 minus 25 minus 7 equal to 0. So 5RA is minus 15 minus 25 is minus 40, minus 40, and minus 7 will be minus 47. I hope that's right. Okay, so RA is 47 divided by 5. Okay, RA is 47 divided by 5. So calculate that now. Can you do that for me? 15 plus 25 plus 7, and that divided by 5 gives you 9.4 kilonewton of force. Okay, and because we have very limited space, I'm going to erase this. Okay, so we know that this was 9.4. Let me use a different ink. RA was 9.4 kilonewton. Okay, so now let's find the value for RD. Like I said, you don't have to use moment anymore. All you need to do is find the total forces. You know that forces in this system, when it's equilibrium, should be equivalent to 0. Okay, so RA is 9.4. Now you use the direction of the arrow to determine whether you want to put a positive or a negative value. Okay, 9.4 minus 5 minus 10 minus 7 plus RD equals to 0. Okay, so 9.4 minus 5 minus 10 and minus 7 gives you 12.6 kilonewtons. So your RD will be 12.6 kilonewton, and that solves the problem. Okay, so basically what we have done today is just looking at simple beams which has a support at two ends. Okay, but like I said, it is not always the case that where you will have supports at either ends. Okay, if you look at slide number 29, you can see that your RA and RB is now in the middle of the diagram, but the concept is still the same. You just choose either RA or RB as your pivoting point, and then you redirect all the other forces towards that pivoting point. Okay, so firstly what you need to do is, when you have a uniformly distributed load or UDL, you simplify that first. You'll usually be given the intensity or the magnitude of that. You take that and multiply it with the distance that it covers in the beam. Okay, if it covers the whole beam, then you multiply with the whole distance of the beam. If it covers just a certain distance, then you multiply it with that. So once you're done with that, with the value that you get, you will then put the force in the middle of the total distance. Okay, in the middle of the UDL. Okay, that means that the UDL is now cancelled and is represented by only one single force or a point load. And then you can work on the problem as usual. You just use moments, find a pivoting point, redirect all the forces, multiply it with perpendicular distances towards that pivoting point. And then once you found one of the support, the value of one of the support, you now then find the other value of the support of the beam by adding all those forces up together. Okay, so you know that now in an equilibrium system, all the total forces will be equivalent to 0 as well. So when the arrow is pointing upwards, it will be positive, arrow pointing downwards negative. Add them up and then you will be able to get the other value for the support, for in this case for RD. Okay, so you have many other examples in the slides, and I would suggest that you try each one of them out. If you're confident enough, you can proceed with your P2 in your assignment. And once you're done with that, you can submit your assignment to me. So that's all for static systems. That's all for moments and forces. In the next lesson, we will be looking at stresses and strains. So I do suggest that you try and take a look at the slides before I start teaching you, so that you will have a basic idea about what we're going to talk about. All right, till I see you again. Bye.